Okay, today we're going to have a look in trigonometry at finding an angle that's been given or that's missing in a triangle. We're going to use our three trig ratios. The three trig ratios are sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. You can remember it by sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent, SOHCAHTOA. The steps are going to be based on what we learned in the last lesson. The first thing you need to do is label the given sides. So not all the sides in the triangle today, but the given sides. And then once you've labelled the given sides, that will let you choose the rule. So in our triangle today, we're going to have a missing angle and we're going to have two marked side lengths. Now with our marked side lengths, we need to work out if they're opposite sides, adjacent sides or hypotenuse sides. And we learnt in the last lesson that that was all based on this angle theta. So if we have a look at our angle theta, we actually don't have anything that's opposite the angle today. We do have a hypotenuse that's there. So the other side, if it's not a hypotenuse and it's not an opposite, it is an adjacent side. So when we go back and have a look at our rules, the one that's got an A and an H in it is cos. So we're in fact going to be using our cos rule. Cos theta equals adjacent over hypotenuse in order to solve the mystery of how big theta is. So if we jump in and now use our formula to substitute, we have cos theta equals our adjacent side is 20 and our hypotenuse is 25. Now we don't want to find cos theta, we just want theta. So like when we do any other equation, we need to get rid of this cos. So we're going to put it on the other side of the equal sign and we're going to turn it into a cos minus 1. And we've got 20 over 25. Now, if you get your calculator out at this point and have a look for the trig functions of sine, cos and tan. And if you look above them, you'll see a sine minus 1, a cos minus 1 and a tan minus 1. And it means that little minus 1 in the air means the inverse of or the opposite of. So that's what we're going to use. When you turn your calculator on, you need to check that somewhere along the top is a D for degrees sign. So check it's in degrees. If it's not in degrees, you'll get the wrong answer. And you need to check, where these signs are. So I'm going to use my calculator and type in what I've got here in my equation. So it says cos minus 1. So I'm going to do cos minus 1, 20 over 25. It equals, and I'm going to get that theta equals 36.86989. And you can round that off to theta equals 37 degrees to the nearest degree. So it won't matter. Well, I'll put that up so you can actually see the answer. So it won't matter whether we're doing sine, cos or tan. Putting it in your calculator is just pressing the right button. The steps are going to be exactly the same. So we'll have another look at an example. And I'm going to write SOHCAHTOA at the top of my page so I can check the rule. I'm going to draw a triangle for us to have a look at. Put the theta up the top this time. And let's say that this side is 36 meters and this side is 42 meters. And we'll go from there. So my very first step is to label the sides that have been given to me. So from theta, I've got an opposite side. I don't have a hypotenuse, so there's no hypotenuse to mark in, but I do have an adjacent side. So I've got an opposite and an adjacent. So I look through my rules until I see the opposite and the adjacent, and it tells me it's with tan. So tan theta is opposite over adjacent, and I go through the steps again. So tan theta, the opposite side is 36, the adjacent side is 42. I need to get rid of the tan, so I'm going to make that the inverse, or tan minus 1. I put my fraction in here, and then I pop it in my calculator. So second function, or shift tan, depending on your calculator, 36 over 42. Close my brackets, press equals, and I get that theta equals 40.6 degrees, 1 dp. Have a look at another example. Let's make up some numbers. 35 centimetres, 56 centimetres. So have a look. From our angle that's been given to us, we've got nothing across there, so there's no opposite. Check out my hypotenuse. I do have one of those. And I've got an adjacent. So an adjacent and a hypotenuse, that's the cos rule. So cos theta is adjacent over hypotenuse. Cos theta adjacent is 35. Hypotenuse is 56. We don't want the cos, we need to get rid of it. So cos minus 1. Pop my fraction in. I'm going to pop that in my calculator. Shift cos of 35 over 56. Apologies if you can hear Madeline screaming in the background. I think she's losing the game she's playing. Is 51.3 degrees to 1 decimal place. Now, if you wanted to, you can press this little degrees button here, and it turns it into degrees, minutes, and seconds. So it looks like commas, but it's degrees, minutes, and seconds. So they're the examples for today. We didn't do a sine one, but it's the same as anything else that we've done here. You just have to press a button on your calculator. We mark the sides we've been given. So not all of them, just the ones we've been given on our triangle. That lets us pick the rule. We write the rule, we substitute in. We're always going to be shifting that across to the other side of the equal sign. So we get the minus 1, and then we use our calculator, find that button and press it. So make sure it's not just cos, but we're doing the shift cos to make sure it's got the minus 1 on the screen. And if you do that, then you will get the right answer every single time.